This video is to help you to create a histogram from a grouped frequency distribution. So let's have a look at our distribution. I'm using a set of data from exercise 145, page 365, question 3. And I want to represent this data on a histogram. So we need to decide on the range of our data, which is the smallest value, 20.5, up to the highest value, which is around 23.4 here. And then we're going to put it into groups. We might be particularly interested in one particular part of the data. What's going on, for example, between 21 and 22. So I want to divide that into smaller groups. But I'm not particularly interested in what's happening in other parts of the distribution, so I might make those group sizes a bit bigger. And the histogram helps us to represent that data in an accurate way. So it's particularly useful if we've got different sized groups. So we need to decide on the groups we're going to produce, and then have a table, and we can put that data into the table. So we need to generate columns in a table. But before we do that, let's just talk briefly about what the histogram is, and that will help us to decide on the columns that we need in this table. So if we're going to plot a histogram, it looks very like a bar chart. So I have my x and y axes, and then you will see on the histogram bars. That may not be of equal size. And the trouble with ordinary bar charts is we tend to think of the size of the group as being associated with the height. And so the height of the bar is all that we're interested in, because that gives us a frequency, the number of pieces of data in each group. In a histogram, it's the area of the bar that represents the frequency. So looking at the number of people in this group, it looks as though that group here, this one, has actually got a bigger frequency than this one, even though this bar here is higher than this bar. So the area of the bar is what determines the frequency. So up the y-axis, we don't plot frequency, we plot something called frequency density, FD, for frequency density. And along the x-axis goes the x values. And we tend to start each bar at the lowest value of the group, so that will be the lowest class boundary, LCB. This will be the upper class boundary from that group. In a histogram, there are no gaps in between the bars, so the lower class boundary of the following group, which is this large square here, must be the same as the lower class boundary. So the upper class boundary of the previous bar must be the same as the lower class boundary of the next bar, so they must coincide. So lower class boundary of the next group, we then go to the upper class boundary of that group, which will form the lower class boundary of the next bar, and so on, up to the upper class boundary of that group, which forms the lower class boundary of that, and so on. So that's what we're going to plot on the axes. The only question is, how do we decide on a frequency density? Well, the formula for frequency density is the value of the frequency for that particular group divided by the class width, the width of the group. And if you think about it, the area of a rectangle is always going to be that side, which is in this case the frequency multiplied by the width. So the frequency density, which is this column, multiplied by the width of the group will give us the frequency. And if I rearrange this formula, you can see that frequency equals frequency density multiplied by the width of the group. So if I multiply one column, the frequency density column, by the width column, I'll get the frequency, which is the area. So that's what we've got to do. We've got to generate a column to find the frequency density. we've got to find the lower class boundary of the group and the upper class boundary of the group, and we've got to find the frequency of the group so that we can generate the frequency density. And that's what we're going to do. So for all this data, in our group, we decide on the group sizes, and in this particular one, I'm not interested particularly in what's going on between 20 and 21, so really that's all in one group from 20 to 20.9. The next group starts at 21 and goes up to 21.2, so you can see that's a much smaller group size, and so on. And then when I get up to around about 22, I'm not really interested in what's going on between there, so they're much bigger groups. So I'm focusing in on the area between 21 and 22, and that's shown by the group sizes. So now I go through and generate my tally table for each of the pieces of data. Which group does it go into? I find the frequency of that group, and then I want the upper class boundary for each group and the lower class boundary, the width of the group, which I can calculate in the frequency density. So let's have a look at that. So I've generated my tally chart in the same way as we would for any group frequency distribution, which means I can find the frequency of the group. And now put in the lower class boundary. So if we start with the top one, the lower class boundary, 20, is the lowest value in the group, 20. The upper class boundary, though, forms the start of the next group. So the upper class boundary, 21, is the start of the next group. The upper class boundary must be the same as the lower class boundary for the next group, so they must be the same. So that means the upper class boundary for the next group will be the start of the following one, and so on. So 21.3 forms the lowest class boundary for the third group. 21.6, which is the upper class boundary, is the lowest value of the following group, and so on. So lower class boundary and upper class boundary put in the columns. And then we find the width of the group, which is just straightforward subtraction. 21, which is the upper class boundary, minus the lower class boundary, 20, gives us a value of 1. The upper class boundary, 21.3, minus the lower class boundary, 21, gives us a width of 0.3, and so on. So we can now complete that, and we find the widths of the group. And now, finally, we need the frequency density. And remember, to find the frequency density from the formula, it's the frequency divided by the width of the group. So it's this number, the frequency, divided by the width of the group. 3 divided by 1 is 1, and so on. 6 divided by 0.3 is 20. And in that way we can complete the column and end up with the frequency density. So now we're in a position to plot our histogram, and what we need to plot is on the y-axis the frequency density, which is this column here, and on the x-axis we're going to plot these values, the lower class boundary and the upper class boundary. So we're going to start our bar on the lower class boundary and then finish it on the upper class boundary. So we need a set of axes, and we can see on the x-axis I've started around about 19.520 and gone up to 24.525, so I can get all my groups on there. The frequency density will start at 0 and go up to at least the highest value for the frequency density, which we can see is 26.7. So I've gone up to 30. So now, if we look at the first bar, it starts at lower class boundary of 20 rather, and goes up to 21. So to put this on our chart, I'm going to start at 20 and go up to 21. So starting at 20, which is here, so that's that point, and going up to 21. So my bar is going to start at 20 and finish at 21. And what's the height of the group? It's going up to go up to a frequency density of 3, this value here. So it goes up to 3. So 3. So there's my first bar. So I'm plotting here, not label this, x, which is the value in the group, and this is frequency density. So the next bar starts at 21, so at the same point, and goes up to 21.3 and goes up to a height of 20. So starting at 21, going up to 21.3, which is here, but now we want to go up to a height of 20, so this bar is going to go up to that point there, so then I complete my bar. And so on, to complete the histogram. So there's our completed histogram. Look at the histogram and just check for yourself that you agree with what I've done there. Now, just by looking at it, we can see that actually the biggest group, the one with the highest frequency, is this value here. This group has got the highest frequency because it's got the biggest area. So that is more representative than the bar chart. It's not the height of the group that gives you the size. The highest group is the group, well, this group here. It's the one with the biggest area.